Our lesson today deals with our universe, how scientists believe our universe was created, and how we measure distances in our solar system, in our galaxy, and in our universe. The most popular theory among scientists for how our universe became into being or was created is called the Big Bang Theory. And the Big Bang Theory states that somewhere between 13 and 14 billion years ago, all of the matter that's now in the universe was all pinned up in one tiny point, and that for some reason, all of this matter, and this matter was not the matter like we see it today. There were no atoms. There were only the building blocks to atoms. But then for some reason, all of this matter began to expand. And expanded very rapidly. And after its expansion, the subatomic particles that began to form atoms, and over time, galaxies were formed, and planets were formed, and it was the formation of the entire universe. Now, this is the accepted theory among scientists today, and for more information about the Big Bang, I suggest that you watch the Khan Academy video, the introduction to the Big Bang, which will give you quite a bit more information about the Big Bang theory itself. One of the most important pieces of evidence for the Big Bang is called the redshift. And this takes us back to the electromagnetic spectrum. Let's just worry right now with the electromagnetic spectrum with visible light. And as you can see here, we have the visible light spectrum. Well, what happens with visible light when an object is moving towards us and that object puts out visible light, or any of the electromagnetic waves, those waves are pushed together, as you can see in this diagram here. And that's called a blue shift. If an object that is putting out visible light waves is moving away from us, then those waves are stretched out. And as you can see here, this is called the redshift. Everything that is redshifted shifts towards the red end of the spectrum, and the wavelengths become longer. Well, what scientists realized many years ago was that every time they took a spectrum of a distant galaxy, it was redshifted, which means it was moving away from us. And the farther away the galaxy was, the greater the redshift, which means that it was moving away faster. So everything that we have found in our universe outside the local group, and the local group is a group of about 20 galaxies, including our own Milky Way galaxy, those galaxies are held together by gravity. But everything outside of the local group is redshifted. And every galaxy that is farther away than the next has a greater redshift. So we know that the universe is expanding, and the farther away, the faster the expansion. So now let's talk a little bit about measuring distances on Earth, in our solar system, in our galaxy, and in our universe. On Earth, when we measure distances, when we travel either by automobile or by train or by airplane, we measure distances in miles or in kilometers. But our solar system and our galaxy and our universe, if it is so large that when we try to deal with miles or kilometers, the numbers really get too big. So if we're looking at distances measured in our solar system, from the Earth to the Sun, and of course this diagram really is not to scale by any means, but from the Earth to the Sun, the measurement in miles is about 93 million miles. And in kilometers, it's about 150 million kilometers. This is miles and this is kilometers. But those are big numbers to deal with, and our solar system stretches way out. So we came up with another useful measurement to measure these distances. And we came up with what is known as an astronomical unit. And an astronomical unit, is also known as an AU. And an AU is the distance from the Earth to the Sun. And so we can talk about our distances from our Earth to different planets in astronomical units, which makes it much easier since the distance from the Earth to the Sun is 1 AU. Then that makes it much easier to deal with than talking about miles or kilometers in the millions. When we go past our solar system and start looking at our galaxy and our entire universe, even astronomical units are not large enough to use as a measuring device. So when we go beyond our solar system, we start using a measurement called light years. And light years is a measurement of distance. Light years measures distance. If you think about it, imagine that this galaxy is the Milky Way galaxy. If this was the Milky Way, this is another distant galaxy, obviously it's not the Milky Way, but if it was, our solar system is just, I'm going to put a little red tiny dot out here. Our solar system is way out here, and probably that dot is too large to represent our entire solar system. Yes, that would be our solar system. And look at the expansion, the size of the galaxy compared to that one tiny little red dot there. There it is right there. So our galaxy is way too large to use astronomical units. So we measure light years. And light years, a light year is how far light travels in 1 year. Now, to think about that, we need to talk about light speed. Light speed, the speed of light, is 186,000 miles per second. That's about 300,000 kilometers per second. And so when we start talking about distances in our galaxy or distances in our universe, we're talking about extremely large distances. And just so you understand, traveling at 186,000 miles per second, it takes light over 8 minutes to go from the sun to the earth. And the next star closest to the earth from the sun, closest to the earth other than the sun, is a star called Alpha Centauri. And Alpha Centauri actually is a group of stars, and Proxima Centauri is the closest star in that group to us, and it's over 4 light years away. So traveling at 186,000 miles per second, it takes light from Proxima Centauri over 4 years to reach the Earth. That's an astronomical distance. So when we talk about the distance to Proxima Centauri, we talk about its distance as 4 light years. And that's very close, considering that our entire galaxy is over 100,000 light years across and about 30,000 light years thick. It's a huge place. And our galaxy, the Milky Way, is just one of over 100 billion galaxies in our universe. And the nearest galaxy to us is in the one of the galaxies in the local group is Andromeda. Andromeda is millions of light years from our galaxy, and other galaxies are millions, hundreds of millions, and billions of light years away from us. And everywhere we look in the universe, there are galaxies. And remember, these galaxies are all moving away from us. They're all redshifted, except for those galaxies in the local group. And this is our reason for believing that at one point, all of the matter in the universe was all packed together in one place, known as, and began to expand some 13 billion years ago, and this is known as the Big Bang.